So all the above mentioned conditions are for two things, are for two cases. So you can remember that, as you can note it in your rough notebook or where you are doing your practice. So hey guys, this is Nishan Paliwal and today we will discuss about exercise 3.2 question number 2 and question number 3. Earlier we discussed about question number 1 of this exercise and exercise 3.1. Also we have discussed all the concepts from this chapter, so if you have any confusion you can refer to those videos. Today we will do exercise 3.2 question number 2 and question number 3. Before starting the question, I want to revise some concepts with you. So here we go. The question 2 and question 3 asking about the pairs of lines, whether these are intersecting, coincident or parallel. So by observing the equation, I want to tell you how you can check that the lines are intersecting, parallel or coincident. So as we discussed, you know what are intersecting lines. If this is y-axis, this is x-axis and this is our graph, then if this is the line of first equation, then this is the line of second equation. So these type of lines are known as intersecting lines. Here these both lines meet at one point. The condition for intersecting lines is a1 upon a2 is not equal to b1 upon b2 is not equal to c1 upon c2. The condition is this. Now what are a1, a2, b1, b2 and c1, c2? Let us see. As we know that the linear equation in two variables have general form as a1x plus b1y plus c1 equal to 0 for one equation, and for other equation it is a2x plus b2y plus c2 equal to 0. So if you are given any linear equation in two variable in this form, then you can directly, by observing the coefficient of x, y and the constant term, you can tell us that the lines are intersecting. If the ratio of a1 and a2 is not equal to b1 and b2 is not equal to ratio of c1 and c2, then these lines are intersecting lines. Or we can say they have one solution or unique solution. I have discussed this before also in one of my concepts lecture. So if you want to go in detail, you have to refer to those lectures. So if the lines are intersecting, then this is the condition. If lines are parallel, like this, they are parallel lines, then the condition is a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. It means the ratio of coefficient of x and ratio of coefficient of y in both the equation is equal, but it is not equal to the ratio of constant terms. It is known as, since we know that the solution, if we talk about solution, what is the solution? Solution means the point where the lines formed by these both equation intersect. So here it is intersecting at one point, so it is one solution or unique solution. Here it is intersecting nowhere. These are parallel lines, they are not intersecting, so there will be no solution. Similarly, for coincident lines, means overlapping lines. If the line of first equation is this, then the line of second equation will overlap upon this. Understand? So the condition is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. It means the ratio of coefficient of x to the ratio of coefficient of y and the ratio of coefficient of constant terms, all the three are equal. Here if we talk about the solution, C, at each and every point upon this line, at each and every point on this, the second line is intersecting it. If the first line is this, then here also, here, at all the points the second line is intersecting it. So it has infinite solution. It has infinite solution, or we can say that infinitely many solution. So what you need to remember, this condition is for two cases. First, if you are asked check whether the lines formed by these equations are intersecting or not, then you have to apply this condition. If you are asked check whether the solution given by these lines is unique solution or not, then you have to apply this condition. If it is asked check whether the lines are parallel or not, then you have to apply this condition. If it is asked check whether the lines, these both equation have solution or not, then you have to see this, check for that. If it is asked check whether these lines are coincident or not, then you have to apply this condition. If it is asked check whether these have infinitely many solutions or not, so you have to apply this condition. So all the above mentioned condition are for two things, are for two cases. So you can remember that, as you can note in your rough notebook or where you are doing your practice. So please note it, pause the video and then note it. Okay, hope you have copied. Now there are two more terms which are called consistent equations and inconsistent. The equation which have solution are known as consistent equation, and the equation which don't have solution are known as inconsistent solution. The equation which have solution are known as consistent equation, and which don't have solution are known as inconsistent equation. So now coming back to this, here how can we define consistent and inconsistent? So as we know, the equation which have solution are consistent equation. So this the pair of intersecting lines has one solution, so we can call it as consistent solution. Okay, the pair of intersecting lines have one solution, as they are meeting at this point, so we can say that it is the condition for consistent solution also. Here we have infinitely many solutions. It means we have solution, but they are uncountable, they are infinite, but we have solution, so this can also be called consistent. Here we have no solution, we don't have any solution here, these lines are not intersecting at any of the point, so this case is inconsistent. So for consistent there are two cases. First is intersecting lines or unique solution, or coincident lines or infinitely many solutions. For inconsistent we have one case, that is parallel lines or no solution. Got it? Now please copy it in your notebook. Okay, now we are going to start our question. Here is the revision of previous some concepts which we need to know before going to these questions. So here second question asks us, on comparing the ratios a1 a2 upon b1 b2 and c1 c2, find out whether the lines representing the following linear equation intersect at point, are parallel or coincident. Here if you read the question, it is written that linear equation intersect at a point. At a point it means it is asking about intersecting lines. At single point it is intersecting. Okay, so if we see the first equation, then it is 5x here minus 4y plus 8 equal to 0, and second equation is 7x plus 6y minus 9 equal to 0. 7x plus 6y minus 9 equal to 0. Okay, so we need to compare the coefficients to check whether the lines are intersecting, parallel or coincident. So what is a1 here? Here a1 is 5, here a2 is 7. a1 the coefficient of x in first equation, a2 the coefficient of x in second equation, b1 the coefficient of y in first equation, so it is negative of 4, and b2 coefficient of x in second equation, so it is 6. Here c1 is constant term in first equation, so it is 8, and c2 is constant term in second equation, it is minus 9. Now we need to divide all of them and check whether these lines are intersecting, parallel or coincident. So here we go, a1 upon a2 is equal to 5 upon 7. They cannot be reduced further. b1 upon b2 is equal to minus 4 upon 6, that is equal to minus 2 upon 3. c1 upon c2 is equal to 8 upon minus 9, which cannot be reduced further. So as we see, a1 upon a2 is not equal to b1 upon b2, is not equal to c1 upon c2. All the three ratios are unequal. So what we can conclude about this, that the following pairs of equation represent intersecting lines. As we discussed ago, intersecting lines. So these pair of equation represent intersecting lines. When we plot these both equation in a graph, then we will see that the line formed by these both equation is intersecting lines. They will intersect at a single point. Okay, or we can say that they have unique solution, which is not asked in question. In next question it is asked. So here we can write only this much. So this is your complete answer, which you need to write in your board examination or in your school examination to get full marks. You can copy it. Just pause the video and copy. Okay, now I am going to do a second question. Okay. Now the second question asked, second part of this question says 9x plus 3y equal to 12. 9x plus 3y equal to 12 and 18x plus 16y plus 24. Sorry, it is not equal to 12. It is plus 12 equal to 0. And second equation says that 18x plus 6y plus 24. 18x plus 6y plus 24 equal to 0. So here a1 is equal to 9, the coefficient of x in first equation. A2 is equal to 18, the coefficient of x in second equation. b1 is equal to 3, the coefficient of y in first equation. b2 is equal to 6, the coefficient of y in second equation. c1 is equal to 2, the constant term in first equation, and c2 is equal to 24, the constant term in second equation. Understand? Now if we divide them, this is 9 upon 18, which is equals to 1 upon 2. This b1 upon b2 is equal to 3 upon 6, which is also equal to 1 upon 2. c1 upon c2 is 12 upon 24, which is also equal to 1 upon 2. So here we can see that a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. All the three ratios are equal. So what can we conclude about that? We can conclude that the following pairs of equation represent coincident lines. Coincident lines. The following pair represents coincident line. You need to remember these conditions. Or we can say that they have infinitely many solutions. They have infinitely many solutions. So you can note down this. This is second part. Okay. Please pause the video, and if you want to note, then note. I am going towards third part. Now third part says that Now third part says that 6x minus 3y plus 10 equal to 0. 6x minus 3y plus 10 equal to 0. This is third part, okay? This is third part. And other equation is 2x minus y plus 9 equal to 0. 2x minus y plus 9 equal to 0. Here also the same thing we will do. We will find out the a1, a2, b1, b2 and c1, c2, and then we will compare the ratios. Okay, so a1 is 6. The coefficient of x in first equation in a2 is 2. Sorry, a2 is 2. The coefficient of x in second equation. Here b1 is minus 3. Remember this. You need to write the numbers here with their respective signs which they have in their equations. So you need to check the sign whether it is positive or negative, then you have to write here. Okay, so it is b1 b2, b1 this and b2 minus 1, coefficient of y in first equation, second equation, so it is minus 1. c1 is 10 and c2 is 9. So a1 upon a2 is 6 upon 2, b1 upon b2 is minus 3 upon minus 1, it is equal to 3, it is equal to 3, and c1 upon c2 is 10 upon 9. Okay, so as we can see that the ratio of a1 and a2 is equal to b1 and b2. So here it is equal and here it is not equal. So this condition tells us about the parallel lines, that these pair of lines are parallel lines. So the following pair of equation represent parallel lines. As a1 upon a2 and the b1 upon b2 are equal, but it is not equal to c1 upon c2. So this tells us about parallel lines. Okay, understand? Or we can say that no solution, that these equations don't have any solution. If we assume these equations, if we imagine these equations in graph, then we will see that both the lines are parallel. Okay, just note it down. Then we will move towards third question. It is having 5 parts. Okay, so in third question it is asking on comparing the ratios a1 upon a2, b1 upon b2 and c1 upon c2, find out whether the following pair of linear equations are consistent or inconsistent. It is asking that the following pair of linear equations are consistent or inconsistent. So there are 2 methods to check this. First method, you apply this a1 upon a2, b1 upon b2. If the lines are intersecting or coincident, then they are consistent, as we have discussed earlier. And if the lines are parallel, then it is inconsistent. Or other method is you solve both the equation. If you get the solution, then they are consistent. If you don't get the solution, then they are inconsistent. Or you imagine both the equation, you draw. So the second question asks us to check the consistency and inconsistency of the equation, whether the following equation represent a consistent solution or an inconsistent solution. So to check that, we have 3 methods. First one, by comparing the coefficients, we can check that whether the lines are intersecting, parallel or coincident. Remember, if the lines are intersecting or coincident, then the equations are consistent equation. It means they have solution. Remember this point, note in your notebook. If the lines are intersecting or coincident, it means they have solution and they are consistent, because consistent means that the equation should have solution. And if the lines are parallel, then they are inconsistent. It means they have no solution. So first method is to check by the coefficient. Second method is by solving the following equation algebraically, and if you are able to find the solution, then it is consistent, and if you are unable to find the solution, then it is inconsistent. And third method is to plot these points in the graph, which is useless method. Okay, So third method is to plot these points in the graph and see the lines representing intersecting, coincident or parallel, and get your answer. So we will do with the comparing the coefficient method, which we have done in previous second question. So third question first part says that 3x plus 2y equal to 5, 3x plus 2y equal to 5 and 2x minus 3y equal to 7. These are the two equations which we need to consider. So here a1, a2, b1, b2 and c1, c2. As we have done three questions on the basis of this only, so till now you have learned that a1 is equal to coefficient of x in first equation and a2 is coefficient of x in second equation. b1 is coefficient of y in first equation and b2 is coefficient of y in second equation. And remember this point, you need to write the number with the respective sign it has in the equation. If the number in the equation is negative, then you have to write here negative. If it is positive, then you have to write it positive. Okay, you have to write number with the respective sign. c1 is plus 5 and c2 is plus 7. Now if we take the ratios, it is a1 upon a2 which is equals to 3 upon 2, b1 upon b2 which is equals to 2 upon minus 3 and c1 upon c2 which is equals to 5 upon 7. So as we can see that all the three ratios are unequal. All the three ratios are unequal. So if the ratios are equal, then we know that the lines are intersecting. If the ratios, all the three ratios are unequal, then we know that the lines are intersecting. So the following pair of equation represent intersecting lines, and we know that intersecting lines have solution. Intersecting lines have solution. So if intersecting lines have solution, then they are consistent. So we can write here the following pair of equation represent consistent solution. The following pair of equation represent consistent solution. The following pair of equation represent consistent solution, and that's the way you have to write in your CBSE board examination or in your school examination. This is the method where you can't lose any marks, where the teacher cannot deduct your any of the marks. Okay, so please note it in your rough notebook or where you are copying. Pause the video and then copy. I am going towards the second question, second part. So the second part says that the second part says that 2x minus 3y is equal to 8. 2x minus 3y equals to 8 and 4x minus 6y equal to 9. 4x minus 6y equal to 9. So a1 is 2, a2 is 4, b1 is 3, b1 is minus 3 and b2 is minus 6. Remember, you have to write with the sign. It is negative of 6, it is negative of 3. So here also it is negative of 6, negative of 3. And c1 is equals to 8 and c2 is equals to 9. So if we see the ratios, a1 upon a2 is equals to 1 upon 2, b1 upon b2 is equals to 1 upon 2, minus and minus got cancelled, 3 upon 6 equal to 1 upon 2, and c1 upon c2 are 8 upon 9, which cannot be reduced further. So a1 upon a2 is equal to b1 upon b2, but it is not equal to c1 upon c2. So the first pair of ratios are equal and the second pair of ratios are unequal. So this is the condition for parallel lines. If we plot these equation in a graph, then they will represent a parallel line. the pair of parallel line, and parallel lines do not intersect anywhere in the graph, so they have no solution. They have no solution. So if they have no solution, then they are inconsistent. They are inconsistent. Remember, consistent means having solution and inconsistent means not having solution. Intersecting and coincident lines have solution, so they are consistent, and parallel lines do not have solution, so they are inconsistent. Okay. Now moving towards third question. Please, if you want to note it, please do pause the video. Moving on to third question, third part of this question. Third part is 3 upon 2x plus 5 upon 3y. 3 upon 2x, third part it is, plus 5 upon 3y equals to 7, and 9x minus 10y equal to 14. 9x minus 10y equal to 14. So if we check the coefficients, then a1 is equals to 3 upon 2, b1 is equals to 5 upon 3, and c1 is equals to 7. Similarly, a2 is equals to 9, b2 is equals to minus 10, you need to write here with the respective sign, and c2 is equals to 14. Now a1 upon a2, which is equals to 3 upon 2 into 9, so it is 1 upon 6. b1 upon b2, 5 upon 3 over minus 10, so this is also 1 over 6, minus 1 over 6, and c1 upon c2 is 7 upon 14, which is equals to 1 upon 2. So we can see that the ratios are 1 upon 6, minus 1 upon 6, and 1 upon 2. So all the three ratios are unequal. It is 1 upon 2, it is minus 1 upon 6, and it is 1 upon 6. They can be equal, but here it is negative sign, so we will consider them that these are unequal. Okay, so all the three ratios are unequal. So this condition is for this. Unequal condition is for intersecting lines. Intersecting lines means they are intersecting at a single point, at one point. So since they are intersecting at one point, they have a solution. So we can say that the following equation represents consistent solution. They have solution, so they are consistent. Having solution is consistency, not having solution is inconsistency. So please do copy it. Okay. Moving on to fourth part of this question. Fourth part, as fourth part is 5x minus 3y equal to 11. Fourth part, 5x minus 3y equals to 11, and minus 10x plus 6y equal to minus 22. So a1 is equals to 5, a2 is equals to minus 10, b1 is equals to minus 3, b2 is equals to 6, c1 equals to 11, and c2 equals to minus 22. We have noted all the coefficients. Now a1 upon a2 is equals to b1 upon b2. So a1 upon a2 is 5 upon minus 10, which is equals to minus 1 over 2. Got it? b1 upon b2 is minus 3 upon 6, which is also minus 1 upon 2. c1 upon c2 is 11 upon minus 22, which is also minus 1 upon 2. Now as we can see that all the three ratios are equal. All the three ratios are equal. It means this condition represents coincident lines, means the lines overlap each other. The lines overlap each other. So at every point on the bottom line, the upper line intersect. At every point both the lines intersect. So they have infinitely many solutions. So we can say that they have solution which are infinite solutions. So these pairs represent consistent solution because they have solution. Okay. Please do copy it. Okay, moving on to fifth part, the last part of this lecture and this question also. The fifth part. The fifth part says that 4 upon 3x. Fifth part, 4 upon 3x plus 2y equal to 8 plus 2y equal to 8 and 2x plus 3y equal to 12. 2x plus 3y equal to 12. So a1 is equals to 4 upon 3, a2 is equals to 2, b1 equals to 2 and b2 is equals to 3, c1 equals to 8 and c2 equals to 12. So 4 upon 3 into 2 equals to 2 upon 3, b2 is also equals to 2 upon 3 and c1 upon c2 is equals to 8 upon 10, which are the factors and multiples of 4, so we can write that 2 upon 3. So as all the ratios are equal again, c1 2 upon 3, 2 upon 3, 2 upon 3, these all the ratios are equal, then it represent coincident lines, and coincident lines have solution, so the following pair of represent consistent solution. Okay, so hope you understand the concept of consistency and inconsistency and intersecting parallel and coincident lines. So until next video, keep practicing.